So now we will prepare our reaction, and remember what the elements that you have to add. You have to have a DNA that has been previously digested. You will have the buffer that is again 10x. Remember the concept of 10x. So if you have 25 microliter of total volume, you put 2.5, and the ligase certain amount that we can vary depending on the experiment, the water to reach the total volume of 25 microliters. So now,
right, so normally when you break up into groups for this experiment, the amount of ligase is going to be different per group. Usually one group will do 1 microliter, the next group 2, the next group 3, the next group 4. So the amount of T4 ligase that you add is going to be different for every group. And likewise, the amount of deionized water that you add is also going to be different because the total volume needs to be 25. So that has to be accounted for. So using the illustration on the board, I'm going to be taking the role of group 3, where 3 microliters of T4 ligase is going to be added, and 15.5 microliters of deionized water will be used. So the first thing we'll add is going to be the DNA. So we're going to use the pipette.
remember this is a 2 to 20 microliters, so if you have to add the DNA is 4 microliters. Can you see? We set it.
Yeah. And I have everything aliquoted out, so I'm going to be taking the Hindi 3 digested DNA. We take
from one tube, Eppendorf tube. These tubes are known as Eppendorf tubes.
4 microliters. And in our reaction tube, we add it.
You remember, you push to the first level your yellow top, the yellow top of your pipette, only to the first level to pick up, and then all the way down to put the liquid in the new tube.
Next, we're going to be adding the 10x ligation buffer, and for that, we need 2.5 microliters. We take our buffer, remove our small amount of 2.5 microliters.
And then you will add to the tube. Remember, very softly you deliver your sample without avoiding bubbles.
Next, we're not going to add the ligase yet. Enzymes should usually be added last, especially ligases. So first, we're going to add our deionized water, which is 15.5 microliters.
Can you see he's using the bottom ring to adjust the volume that you need to add?
So we're going to take our deionized water.
Push your pipette yellow button to the first level and to release the sample all the way down.
And then finally, we'll be adding our 3 microliters of ligase, T4 ligase. And we gently pipette that up and down to mix, being very careful because this is an enzyme, so we don't want to disturb it too much.
As in any experiment, we didn't mention before, but you will have undigested. So in this case, you will put the DNA, you will put the buffer, and water, adjust the water to that level without the presence of the enzyme. So you know what is your original sample and what's your after the ligation or digestion, the same thing. It's important to remember here that the enzyme has a wide spectrum of temperatures that were the best for its function. But here you have to remember the kinetic process. Here you want to use lower temperatures to allow the DNA fragment to stay closer to each other and allow the formation of the phosphodiester bond. We have discussed that in the recitation. The temperature here is important not only for the enzyme but also for kinetic understanding of how the fragments will move and allow the formation of the phosphodiester bond.